It started with a bit of flash and spectacle, the launch and growth of AI, but that's slowly been replaced by skepticism and distrust. Paradoxically, though, we see that distrust becoming more vocal while adoption of the technology still increases. In this week's deep dive, based on the Data Pro newsletter from the 20th of May 2026, we're taking a look at the need to set clear boundaries and understanding what AI can deliver to help make sure it goes from risky novelty to a viable infrastructure asset. If this version's a little bit TLDR for what you're doing right now, you can head over to our YouTube page and check out a summary version of this video from the Data Pro newsletter that we mentioned. It's all there on the front page, it's easy enough to find, and while you're there, why not hit that subscribe button so you can get these updates sent to you directly.
$40 billion. I mean, just think about that number for a second. $40 billion.
It is a genuinely staggering amount of capital.
Right. And that is the amount of capital that enterprise companies have just poured into generative AI over the past couple of years.
Yeah, poured is probably the right word for it.
And yet, here's the crazy part. 95% of those pilot projects are failing to generate a single dime in new revenue.
Not a single dime.
Welcome to today's deep dive. We are really thrilled you're taking the time to unpack this with us.
Absolutely.
Because if you've been following the tech landscape at all, you've probably felt this weird cognitive dissonance lately.
Oh, definitely. We're constantly told that artificial intelligence is revolutionizing the global economy.
Right, but then when you look closely at the corporate earnings or, you look at the internal operational realities of these companies, the math simply isn't mathing.
It really isn't.
So today, our mission is to figure out why. We are going to decode this current backlash against AI for you, especially if you're a complete beginner to the back end of this stuff.
Yeah, we're going to break down exactly why that $40 billion investment is stalling out.
And more importantly, we're mapping out the actionable mechanical steps required to fix the underlying enterprise data issues. Because, spoiler alert, the data architecture is currently causing absolute chaos.
It is. I mean, we are operating in a drastically different climate than we were 3 years ago.
Oh, for sure.
You know, that initial novelty, that moment when the world first saw a chatbot write a sonnet or generate a piece of code that is entirely evaporated in the boardroom.
The honeymoon phase is definitively over.
Exactly. Organizations are now slamming headfirst into a highly complex socio-political and infrastructural reality. The focus has forcibly shifted.
From marveling at the front-end tooling to diagnosing massive failures in the back-end plumbing.
You hit the nail on the head.
And to guide us through this diagnosis, we're pulling from a phenomenal piece of source material today.
It's a great read.
It really is. It's a May 2026 article published in datapro.news by Samuel Williams. It's titled "The Trust Deficit: What the AI Backlash Means to You."
Williams really takes a sledgehammer to the hype here.
He does. He argues that the public backlash we're seeing right now isn't just, cultural noise. It's a massive flashing warning signal about structural instability.
And he backs it up with some pretty jarring polling numbers regarding how the public actually feels about interacting with these systems.
Yeah, let's get into those numbers because they blew my mind.
So the polling data Williams cites from TechStrong.ai paints a picture of a profound trust paradox. We are looking at 46% of registered voters holding explicitly negative feelings toward artificial intelligence.
46%. Almost half.
Right. And only 26% report a positive outlook. Furthermore, 57% of respondents state that they believe the risks of AI fundamentally outweigh its benefits.
So you have a clear majority of the public looking at this technology with active suspicion.
Active suspicion is putting it mildly.
But I'm looking at the next line of this data, and this is where the paradox really kicks in. Usage is actually climbing.
Yeah, this is the fascinating part.
Between December 2025 and March 2026, the adoption and frequent usage of platforms like ChatGPT climbed from 48% to 56%.
Exactly.
So we have a population that fundamentally distrusts the technology, believes the risks outweigh the benefits, but they are logging in and using it more than ever. How does that make sense?
It forces us to separate utility from trust.
Okay, unpack that.
Well, a consumer might use an AI tool to summarize a lengthy PDF because, frankly, it saves them 20 minutes of reading.
Right.
The utility is undeniable. However, they do not trust the integrity of the summary. They don't trust the company processing their data.
And they probably don't trust the long-term societal impact of the tool either.
Exactly. They are utilizing the system purely out of reluctant convenience.
It makes me think of the modern fast food industry,
That's a good comparison.
Yeah, like you might pull into a drive-through because you have 10 minutes between meetings and you just desperately need calories.
Right.
You are actively utilizing the product, but you don't for a second believe the burger is nutritious. You don't trust the supply chain that produced it.
No, of course not.
And if you read an article about the negative health impacts of fast food while you were sitting there eating the fries, you'd probably nod along and agree with it.
You're participating in a system you inherently suspect. That is a highly functional analogy.
Thanks.
And from a business perspective, building your entire corporate infrastructure on a consumer base that treats your product like reluctant fast food is dangerous.
Because they have no loyalty to you.
Precisely. A user base bound to you only by convenience, while harboring deep-seated suspicion, well, they will abandon you the second a more trustworthy or seamless alternative appears.
The foundation is incredibly brittle.
It is, and Williams traces a lot of this public suspicion back to a phenomenon that researchers at Sabanci University are calling AI washing.
Ugh. AI washing. We saw greenwashing a decade ago, right? When companies exaggerated their environmental efforts.
Exactly the same concept.
So how exactly does AI washing work mechanically, and why is it destroying consumer trust so aggressively?
AI washing is the deliberate or sometimes just negligent exaggeration of a system's cognitive capabilities.
Okay.
To understand it mechanically, you really have to look at the difference between rules-based logic and actual machine learning.
Let's do that, because I think people confuse those two all the time.
They do. For decades, software has run on strict if this then that decision trees.
Right.
If a user clicks A, display result B, it is a rigid pre-programmed script.
Just basic code.
Yeah. What companies are doing now is taking those basic legacy rules-based systems, slapping a shiny new user interface on them, and marketing them as autonomous reasoning AI.
So they're basically taking a 2010-era customer service chatbot, the kind that only knows how to route you to a human if you specifically type the word refund, and they're branding it as this advanced cognitive neural network.
Precisely. And by doing that, they are establishing a psychological contract with the consumer that promises intelligent adaptability.
They are promising magic.
They are. But when the system goes into live production and the consumer asks a nuanced, multi-layered question that falls outside that rigid pre-programmed script.
The system instantly breaks down.
Exactly. It completely fails to comprehend the context.
And the consumer immediately realizes there is no actual intelligence there. It's just a rigid script wrapped in deceptive marketing.
Which leads to what the Sabanci University researchers call AI booing.
AI booing. I love that term.
Right. The consumer feels lied to, so they metaphorically boo the product off the stage. This creates a self-reinforcing cycle of mistrust.
Upstream marketing inflation leads directly to downstream operational failure and public rejection.
Which brings us right back to the 95% failure rate for enterprise pilots.
The $40 billion.
Exactly. The $40 billion didn't evaporate because machine learning is a hoax. It evaporated because boardroom expectations were entirely divorced from the reality of what it actually takes to deploy these systems securely and profitably.
So when you strip away the AI washing, what are you left with?
You are left with the hard physics of compute and the messy reality of enterprise data.
Let's talk about the hard physics first, because I think there is a huge tendency to view software as just, ethereal.
Oh, absolutely.
We literally call it the cloud, which implies it's this weightless, invisible mist floating above us.
Right, but it's really not.
No, the source material throws cold water on that idea real fast.
Yeah.
We are hitting physical, geographic roadblocks with this technology.
We are. The cloud is heavily grounded in concrete, steel, electricity, and water.
Yeah.
The rapid expansion of generative AI requires an equally rapid expansion of hyperscale data centers.
And these aren't just normal server rooms.
No, these are colossal industrial facilities housing tens of thousands of specialized servers.
Right.
AI workloads require specialized chips, like GPUs, which run incredibly hot.
Like dangerously hot.
Yes. To prevent the hardware from literally melting, these facilities require staggering amounts of energy for power and millions of gallons of water for evaporative cooling systems.
And the article points out that communities are reaching their breaking point.
They really are.
We are seeing real-world impacts right now, actual water shortages in municipalities that are adjacent to these data centers.
Yeah.
And local residents are seeing their utility bills surge because the regional power grids are being pushed beyond their absolute maximum capacity.
This is no longer an abstract environmental concern relegated to some corporate sustainability report.
No, it's real life.
it is manifested as a hard operational roadblock. The source material highlights that project cancellations for new data centers have actually quadrupled across several key markets.
Quadrupled.
Yeah. We are seeing major tech firms purchase land, drop the architecture, and then they have to scrap the entire project because the local utilities simply cannot guarantee the power supply.
Wow. And Williams also notes that several U.S. state legislatures are currently considering active moratoriums on new data facility construction.
Yes, state governments are looking at pausing all new builds.
So if I'm a CIO and I'm planning this massive AI rollout for 2026, I can't just assume I can buy more server space.
Not at all.
I might literally be forbidden from plugging my servers into the grid.
The physical world is imposing a hard ceiling on the digital hype. Compute power is becoming a scarce, highly regulated, and immensely expensive commodity.
Which fundamentally changes the economic equation.
It does.
If compute is scarce and wildly expensive, you can no longer afford to waste server energy processing garbage.
Exactly. Every cycle of that GPU has to be generating actual value.
Which brings us to exactly why those enterprise pilots are failing. If you do manage to secure the server space, what are you feeding into it?
Usually a mess. Williams calls it the AI tax.
Okay, let's unpack this AI tax.
So the AI tax is the massive operational penalty organizations pay because their foundational data infrastructure is fundamentally broken.
Okay.
Williams cites research from Leon Ginsberg showing that 81% of AI professionals report significant unresolved data quality problems within their core storage system.
Like 81%.
8 out of 10 data professionals.
So they're basically admitting they are trying to fuel a supersonic jet with mud.
That's a very accurate way to picture it.
But I want to understand how a company even gets to this point. The article notes that these AI models often perform beautifully in an isolated test sandbox.
They do.
So why does the model suddenly fail the moment it gets pushed into live production?
Because a test sandbox is a highly curated artificial environment.
Okay.
Data scientists will spend weeks manually cleaning, formatting, and verifying a specific data set just to prove the AI model's algorithm actually works.
So it's pristine in the sandbox.
It is pristine.
Yeah.
But when executives see that success and mandate that the model be connected to the live corporate data pipeline,
The pristine environment vanishes.
exactly. Live enterprise data is inherently messy. It's duplicated, contradictory, and fragmented.
And the article lists a few specific culprits for this mess. It mentions inconsistent master data definitions, missing process logs, and shadow pipelines.
Yes.
Let's translate that for you guys listening. What does an inconsistent master data definition actually look like mechanically inside a global company?
Okay, consider a multinational retailer attempting to use AI to predict global inventory needs.
Sure.
The AI needs to analyze active customers.
Makes sense.
However, the European division's database defines an active customer as anyone who has made a purchase within the last 24 months.
Okay.
But the North American division defines an active customer as anyone who has subscribed to their promotional email list, regardless of purchase history.
Oh, I see. So the AI is looking at two completely different databases, pulling the word customer.
Right.
But the mathematical reality behind that word is entirely different in each system.
It's comparing apples to cinder blocks without even realizing it.
And the AI lacks the human intuition to stop and ask for clarification.
Exactly. It just ingests the contradictory data, runs its statistical analysis, and generates wildly inaccurate inventory predictions.
That's terrifying.
And then combine that with missing process logs.
What are those?
That's where the system has no historical record of how or when certain data points were altered.
Oh, so it's blind to the history of the data.
Yes, so the AI is essentially hallucinating based on corrupted history.
And then you throw in shadow pipelines. I imagine this is like when a department gets tired of waiting for the official IT team to build a data integration, so they just build their own rogue extraction tool.
It happens constantly.
Yeah.
A marketing team will use a third-party tool to scrape customer sentiment data and route it directly into their own local dashboard.
Completely bypassing central IT governance.
Exactly. The AI model, which is operating on the official centralized data lake, has zero visibility into that shadow pipeline.
So it is making decisions while being blind to massive chunks of organizational reality.
Yes.
So how do we fix this? The article lays out a very specific, actionable shift in architecture. It says we have to move away from batch monitoring and implement real-time data observability.
This is a critical shift.
What is the mechanical difference between those two approaches?
Batch monitoring is a legacy approach. It's where data teams run health checks on their systems at scheduled intervals.
Like overnight.
Yeah, perhaps once a night at 2 a.m. or even just once a week. They run a script to verify that the database is synced correctly.
Right.
But AI operates on continuous, real-time ingestion.
Ah.
If a corrupted data file enters the pipeline at 9:00 a.m. and you don't run a batch monitor until 2 a.m. the next day.
Your AI has spent 17 hours making high-stakes, automated decisions based on corrupted data.
Precisely. Real-time observability means the system is actively monitoring the pipeline millisecond by millisecond.
And the author mentions this is crucial for catching something called silent failures.
Yes, silent failures are deadly.
Usually if a pipeline breaks, a server crashes or an error code pops up, an alarm goes off. How does a failure happen silently?
A silent failure occurs when the technical infrastructure remains perfectly intact.
Okay.
Data is flowing, servers are humming, no error codes are thrown. But the statistical or structural nature of the data itself has fundamentally changed.
So the pipeline is delivering data, but the data is poison.
Exactly. The article highlights two primary mechanisms for this: statistical data drift and unexpected schema changes.
Walk me through statistical data drift. That sounds complex.
It's actually pretty intuitive. Let's use an automated mortgage approval AI as an example.
Okay.
The model was trained on historical data from 2015 to 2021. That was an economic environment where average interest rates hovered around 3%.
Right. Cheap money.
So the AI learns all these complex correlations between income, debt, and default risk based on a 3% rate environment.
Makes sense.
But suddenly the macroeconomy shifts,
Right.
interest rates jump to 7%. The technical pipeline feeding new loan applications into the AI hasn't broken. It's still working perfectly.
But the statistical reality of the world has drifted.
Yes.
Yeah.
It has drifted so far from the AI's training data that its risk calculations are fundamentally invalid.
Because it doesn't understand the new economic gravity.
Exactly. It begins approving high-risk loans because it's operating in a reality that no longer exists.
Wow. The machine is working perfectly, but the universe it understands is gone.
Right.
And what about a schema change? A schema is just the blueprint of how a database is organized, right?
Correct. So imagine a software engineer decides to update the customer onboarding web form to improve the user experience.
Okay.
Previously, the form asked for a birth year as a 2-digit integer, like 85.
Simple enough.
The engineer updates the form to require a 4-digit integer. So now it's 1985.
Okay, a minor change.
And the engineer doesn't notify the data engineering team because, well, the form still works.
Right, the pipeline doesn't break.
It is still successfully passing an integer from the web form to the database. But the AI model downstream is mathematically expecting a 2-digit number.
Oh, no!
When it suddenly starts receiving thousands of 4-digit numbers, its age bracket calculations silently shatter.
It thinks everyone is nearly 2,000 years old.
Yes. And it ruins the entire demographic analysis, all without throwing a single server error.
That is wild. So to prevent this, the article suggests organizations need to adopt a data mesh model. How does a data mesh solve this lack of communication?
A data mesh is a radical decentralization of data ownership.
Okay.
Historically, companies pushed all their data into one massive, centralized data lake, managed by a single, overwhelmed IT team.
And that IT team doesn't understand the context of the marketing data or the finance data, right?
Exactly. They just manage the storage.
So it's a massive bottleneck.
A severe one. The data mesh architecture treats data as a decentralized product.
Okay, what does that mean in practice?
It means the department that generates the data owns it. And they are responsible for treating it as a high-quality product that they serve to the rest of the organization.
So the marketing team doesn't just dump their customer files into a lake. They curate it.
Yes.
And the article states they have to govern this with strict SLAs, service level agreements.
Right. The SLA acts as an internal contract.
So the marketing department guarantees to the central AI team what exactly?
They guarantee our active customer data set will be 99.9% accurate, updated in real time, and strictly adhere to this exact structural schema.
So if they want to change the date format from 2 digits to 4 digits...
The SLA forces them to renegotiate the contract with the downstream AI teams before pushing the code.
It enforces accountability at the point of origin. That makes total sense.
It does.
But sometimes the bottleneck isn't organizational. Sometimes it's purely mechanical.
Very true.
Williams touches on this fascinating database limitation that teams hit when they try to scale up. He calls it the Postgres optimization treadmill.
This is a massive issue.
I want to dig into the mechanics of this because I think a lot of people just assume that if you buy more cloud storage, you can process infinite data.
That's a very common misconception.
But it turns out the way traditional databases actually read data fundamentally breaks down under AI workloads.
It is a critical engineering trap. Postgres is arguably one of the most reliable, widely used relational database systems in the entire world.
Right.
It was designed to run the transactional economy. But there is a massive architectural difference between a transactional workload and an analytical AI workload.
Let's break that difference down for the listener. If my bank uses a traditional relational database to handle millions of credit card swipes a second, it's incredibly fast.
It is.
Why can't that same database architecture handle an AI model reading this exact same credit card swipes?
Because of how the data is physically stored and retrieved on the disk,
Okay.
traditional relational databases use row-based storage. Imagine a massive spreadsheet. A single row contains all the information for one transaction. So the date, the customer name, the merchant, the amount, the location.
Right.
When you swipe your credit card, the database performs a transactional write.
Right.
It jumps to one specific row, updates your balance, and closes out.
So it is optimizing for quick, isolated, single-row actions.
Exactly.
Okay. That makes sense. But an AI isn't doing single-row action.
No, an AI performs analytical workloads. It doesn't care about updating your specific balance.
Right.
It wants to scan the merchant and amount columns across 40 million transactions simultaneously to detect a macro pattern in retail spending.
I see the problem. If the data is stored row by row, the database can't just read the amount column by itself.
No, it can't. It is forced to load the entire row, the name, the date, the location, just to extract the one single piece of data the AI actually wants.
Oh, wow. It creates massive input-output bloat.
Massive. The system is loading terabytes of irrelevant data into memory just to read a single column.
That sounds horribly inefficient.
It gets worse. Relational databases use mechanisms like MVCC, multi-version concurrency control,
Wait, what is MVCC?
and WAL, write-ahead logging. These are features designed to ensure that if the server crashes in the middle of your credit card swipe, the transaction safely rolls back and your money isn't lost.
Oh, okay. So they are brilliant for transactional safety.
They are. But for an AI model that just wants to read massive historical data sets, the constant overhead of MVCC and WAL acts like an anchor.
Just dragging down the compute speed.
Exactly.
Hence the optimization treadmill. The engineers don't want to migrate to a completely new architecture, so they just keep trying to tweak the existing database.
Right. They add indexes, they partition tables, it buys them a 10% performance boost here, a 5% boost there.
But they are essentially trying to modify a heavy-duty pickup truck to compete in a Formula One race.
That's a perfect analogy. At a certain point, the sheer physics of row-based storage just caps out.
And that realization is causing a massive vindication for traditional data management practitioners, isn't it?
Oh, absolutely. For the past decade, the professionals certified by DAMA, the Data Management Association, have been begging organizations to focus on metadata management, lineage, and structural architecture,
And they were probably ignored.
often viewed as bureaucratic roadblocks to rapid software development. Yeah.
But now, as these AI pilots hit the wall of data physics, the entire industry is realizing that the rigorous disciplines of the the data management body of knowledge, are the only way to build a functional AI foundation.
The bedrock has to be solid.
Right. But let's assume we do fix the foundation.
Okay.
We enforce the SLAs, we migrate to columnar storage for analytics, we get all the human-generated data perfectly clean.
The ideal scenario.
What happens when the data entering the system is no longer generated by humans? Because this brings us to a phenomenon the article calls model collapse, and mathematically it is terrifying.
It is arguably the most insidious technical risk facing generative AI development today.
Model collapse.
Yes. It occurs when artificial intelligence begins aggressively ingesting and training on its own synthetic outputs.
Okay, let's visualize how this happens for you listening. Historically, large language models were trained by scraping the vast expanse of the internet, right?
Yes. They ingested human-written Wikipedia articles, human-authored books, human-coded software on GitHub, human-generated photographs.
It was all human, but now we're using AI to generate millions of articles, billions of lines of code, and countless synthetic images every single day.
The internet is rapidly filling up with AI output.
Consequently, the newer generations of AI models that are out there scraping the web are no longer learning primarily from human ingenuity.
No, they are scraping and ingesting the synthetic data generated by their predecessors.
It creates a recursive loop.
Exactly.
I was trying to map this out in my head, and the best physical equivalent I can think of is making a photocopy.
Oh, I like that.
Like if you take a crisp, original human document and put it on a copy machine, the first copy looks excellent.
Very high fidelity.
The AI does a great job mimicking the human original, but if you take that synthetic photocopy, put it back in the machine, and make a copy of the copy,
Right.
and then you take that second generation copy and copy it again, by the 10th generation, the sharp edges are completely gone.
The text is muddy.
It devolves into a homogeneous gray blur. The fidelity is completely destroyed.
That physical degradation maps perfectly to the mathematical decay occurring inside these neural networks.
The article points to research from UC San Diego that formalizes this exact process, right?
Yes. The researchers demonstrated mathematically that as recursive generations increase, as AI trains on AI, which trains on AI, the variance within the generated data asymptotically decays toward zero.
It decays towards zero, meaning all diversity of thought, all unique variance gets entirely mathematically erased.
Yes.
Why does that happen? What is mechanically failing inside the AI's pattern recognition?
Is the inevitable result of compounding sampling bias.
Okay, explain that.
If you visualize a standard statistical bell curve representing all human data.
It's just a standard curve.
Right. The fat, bulging middle of that curve represents high probability central patterns.
Okay.
It contains the most common vocabulary, the most typical sentence structures, the most average visual representations of a concept.
The middle of the curve is the overwhelming average.
And the thin trailing edges of the curve, the tail ends, represent rare, unusual, idiosyncratic, or highly unique human data points, the edge cases.
Got it.
When an AI generates synthetic data, its algorithms are heavily weighted to favor probability. It naturally gravitates toward the fat middle of the curve because those patterns are mathematically safer.
As a result, the synthetic output it generates contains slightly fewer of those rare tail-end events than the original human dataset did.
Exactly. So the first generation of AI slightly truncates the edges of the bell curve.
Okay.
And then the second generation of AI comes along and scrapes that synthetic data.
It learns from a dataset where the edges have already been trimmed.
Yes. So it gravitates toward the center of that narrower dataset, trimming the edges even further. With each recursive cycle, the model overrepresents the center and deletes the anomalies.
Yeah.
This is known as mode collapse.
Eventually, the AI becomes utterly incapable of generating or even recognizing anything outside the absolute homogeneous center.
It literally forgets that rare events exist.
And Williams provides a chilling example of what this means for enterprise risk, specifically in the financial services sector.
It's a very real threat there.
Because banks aren't just using AI to write marketing copy, they rely heavily on synthetic data for risk modeling.
Right. Financial institutions face immense regulatory hurdles regarding privacy, as they should.
Sure.
They cannot legally take millions of real, unredacted customer banking profiles and just hand them over to third-party developers to train new algorithmic trading or risk assessment models.
So what do?
To bypass these privacy constraints, banks use generative adversarial networks, GANs, to generate synthetic financial data.
Okay, so they use AI to create fake customer transaction histories. The data statistically mimics real economic behavior, but it doesn't tie back to any real human beings, so it clears the privacy compliance hurdles.
Exactly. The developers then use this synthetic data to train their core predictive AI models.
But consider what happens if the GAN generating that synthetic data suffers from model collapse.
It's disastrous.
The GAN starts gravitating toward the fat middle of the bell curve. It only generates average consumer spending patterns and normal market fluctuations.
And it systematically erases the rare tail-end edge cases.
And in the financial sector, those rare tail-end events are not just trivial anomalies.
Not at all. They are sudden credit defaults, unprecedented liquidity shocks, algorithmic flash crashes, and black swan economic events.
Wow. If the synthetic training data systematically erases the existence of sudden liquidity shocks.
The predictive AI built on top of that data will literally have no mathematical concept that a liquidity shock is even possible.
It deletes the possibility from its own worldview.
Exactly. If you deploy a risk management AI that has been mathematically blinded to black swan events, you have built an engine for catastrophic financial failure.
The model will look at a looming crisis and confidently predict stability. Because it's decayed, homogeneous training data told it that extreme deviations just don't exist.
It's terrifying.
So how do we stop the photocopy from blurring? If the internet is already flooded with synthetic data, how do data engineers prevent their enterprise models from collapsing?
The required operational architecture involves maintaining what researchers call a non-shrinking real data anchor.
A non-shrinking real data anchor, meaning an immutable repository of confirmed human reality.
Yes. An organization must build and meticulously protect a foundational data set comprised exclusively of verified, human-generated data.
Zero AI interference allowed.
Zero. While organizations will absolutely continue to use synthetic data to scale their capabilities and accelerate training speeds, the critical rule is that the absolute volume of real-world human-verified data in their core training pipelines must never decrease.
The article outlines a highly specific, actionable step for enforcing this. It involves programming audited pipeline alerts to enforce strict ingestion ratios.
Yes. You establish a hard mathematical ratio at the ingestion layer.
Like what?
For instance, the pipeline might be programmed to mandate a ratio of 70% verified human data to a maximum of 30% synthetic data.
Okay.
If a massive batch of synthetic data enters the system and pushes that ratio to 31%.
The automated observability tools instantly throw a hard alert and completely halt the training process.
It acts as an emergency brake to prevent the model from drifting into a recursive loop.
But maintaining that 70% human anchor implies you have to know with absolute certainty which data was created by a human and which data was generated by an AI.
Right.
And that sounds incredibly difficult.
It requires immense discipline.
Yeah.
And it naturally transitions us into the internal security crisis happening inside these organizations right now.
Ah, yes.
We have established the rigorous controls required to manage the data flowing into the enterprise models.
But we must now examine the terrifying reality of how sensitive data is leaking out of the enterprise.
Yes.
The article frames this as the invisible breach, and it's driven by a phenomenon called shadow AI.
Shadow AI is a huge problem.
Now, anyone who has worked in corporate IT over the last 15 years remembers the headaches of shadow IT.
Oh, nightmares.
But Williams is adamant that shadow AI is a completely different architectural threat.
The distinction is vital. Shadow IT was fundamentally an infrastructure problem.
Right. It occurred when employees utilized unauthorized hardware or applications to bypass IT bureaucracy.
An engineer might secretly spin up an unapproved AWS server because the internal provisioning process was just too slow.
Or a team might use personal Dropbox accounts to share massive files.
Those rogue endpoints. And while IT departments hated it, they could usually hunt it down.
Because it generated anomalous network traffic.
Exactly.
Right.
Traditional perimeter defenses like firewalls and data loss prevention software were designed to monitor traffic flowing to known, secure IP addresses.
So if a massive corporate file suddenly started transmitting to an unknown, unauthorized Dropbox server,
The firewall would detect the anomalous endpoint and sever the connection.
but shadow AI circumvents that perimeter entirely.
It does.
The article describes it as an invisible breach because the sensitive data leaves the organization through behaviors that appear to the security systems entirely routine and benign.
Shadow AI is not an employee sneaking a rogue server into the building.
Yo.
It is an employee sitting at their approved corporate workstation, using an approved web browser, operating over standard HTTP ports, but carelessly funneling sensitive intellectual property through a third-party AI model.
Give me a mechanical example of how this bypasses the firewall.
Okay, an executive is drafting a highly confidential strategy memo regarding an unannounced corporate merger.
Super sensitive stuff.
Very. They want to refine the tone of the document, so they highlight the proprietary text, copy it, and paste it into a public AI chatbot or an unapproved grammar summarization browser extension.
To the legacy firewall, this action does not look like a massive file transfer to a rogue server.
Not at all. It just looks like standard text being entered into a web application over a standard browser port.
But the reality is that unannounced merger strategy has just been uploaded to a third-party server outside the company's secure boundary.
Exactly. Where it might be logged, analyzed, or even used to train a public LLM.
The employee didn't hack anything, they just copy-pasted.
And the threat vector escalates exponentially when we introduce the concept of agentic AI.
Agentic AI. Williams cites some deeply concerning research from Zscaler regarding autonomous AI agents embedded within trusted SaaS environments.
Yes.
We are talking about tools like Microsoft Copilot or Salesforce Einstein.
Right. These are AI systems that are officially purchased by the company and deeply integrated directly into the software the employees use every single day.
So what's the issue?
The paradigm shift here revolves around permissions.
Okay.
A standard chatbot waits passively for a user prompt. But agentic AI is designed to act autonomously on behalf of the user. Because it is embedded directly into the Microsoft or Salesforce ecosystem, it inherits the exact user-level permissions of the employee operating it.
Meaning the AI agent has the cryptographic clearance to access any SharePoint file, read any internal email thread, and query any secure database that the specific human employee has the credentials to access.
Which creates a scenario for massive, autonomous data siphoning without any malicious intent from the employee whatsoever.
Okay, let's use the Janice in accounting example.
Perfect.
Janice in the finance department does not need to copy and paste sensitive data to cause a breach.
No.
She simply types into her embedded AI assistant, "Please summarize the Q3 financial performance across all internal departments."
And the AI agent, operating with her high-level clearance, autonomously spiders across dozens of secure internal databases.
It pulls highly confidential payroll data, unreleased earnings reports, and proprietary sales forecasts.
It aggregates all of this sensitive data into its context window. If that embedded AI assistant is configured even accidentally by a mismanaged IT setting to call out to an external large language model API to process that massive summarization request.
The agent has just autonomously packaged and transmitted the company's most sensitive financial data right out the front door.
The invisible breach.
The biggest threat to corporate security isn't a malicious hacker running a brute force attack on a firewall.
It's not.
It's a well-intentioned employee innocently asking an AI to optimize their workflow.
And legacy firewalls are entirely blind to this because of the underlying protocols.
Why is that?
Most firewalls are built to inspect stateless HTTP requests. A client asks for a web page, the server sends the packet, the firewall scans it, and the transaction is closed.
Right.
But modern AI chatbots and agentic AI utilize WebSocket protocols.
Wait, what is the mechanical difference with a WebSocket?
A WebSocket creates a persistent bidirectional continuous connection between the user's browser and the AI server.
Oh, so it's not just a one-time request?
Yeah. No, it is a live stream of data that stays open, allowing for a multi-turn continuous conversation.
I see.
Legacy firewalls might inspect the initial request to open the WebSocket, see that it's going to a known web address, and approve it.
But they lack the capability to continuously decrypt and inspect the live stream of data flowing back and forth within that open socket.
Exactly. The data flows right past the security perimeter in real time.
So how do organizations close this massive vulnerability? The article outlines a strict 30-day program for enterprise containment.
Yes, it's a very aggressive timeline.
Let's walk through the actionable steps of this roadmap.
The 30-day program forces an organization out of willful blindness. Phase 1 covers days 1 through 10.
Okay.
It is solely focused on establishing real-time visibility. Organizations must deploy modern Security Service Edge or SSE architectures capable of inspecting WebSocket traffic.
So you have to identify every single AI application, API endpoint, and browser extension being accessed by employees across the entire network.
You essentially map the shadow network. You discover the 70 different rogue AI tools your employees are secretly using to do their jobs.
And then we move to phase 2, days 11 through 20.
Phase 2 shifts from passive visibility to active inline inspection and interception.
The security team implements data loss prevention algorithms that actively read the context of the prompts flowing through those WebSockets.
So the system is scanning the outgoing text in real time, looking for specific patterns.
What exactly is it looking for?
It is utilizing natural language processing to identify proprietary source code, internal authentication credentials, API keys.
And personally identifiable information PII, such as social security numbers, healthcare records, or unreleased financial data.
Right. So if an engineer gets lazy and pastes a block of proprietary Python code into a public AI to debug it,
the inline inspection system recognizes the syntax as proprietary corporate code and instantly terminates the WebSocket connection, blocking the transmission and throwing an alert.
it creates a hard barrier.
Okay, but the final phase of the 30-day program, days 21 through 30, that seems crucial.
It is arguably the most important part. You cannot simply maintain a blanket prohibition.
Why not?
The first law of enterprise IT governance is that flat-out bans without viable alternatives only drive user behavior further underground.
So if you block all AI access on the corporate network,
Employees will simply start emailing proprietary documents to their personal phones to use AI off-network.
which creates an infinitely more dangerous security nightmare.
Exactly. You have to give them a safe playground.
So the final phase requires the IT department to deploy highly secure, sanctioned, ring-fenced internal AI tools.
You give the employees the summarization and coding utility they're desperately craving, but you mandate that the data never leaves the internal corporate cloud.
You provide the utility, but you maintain absolute sovereign control over the infrastructure.
Which perfectly sets up our final segment today.
Yes, because we have to address the core mechanism that underpins everything we've talked about.
We do.
To solve the external public trust deficit and to execute the internal data governance required to stop model collapse and shadow AI, organizations must fundamentally restructure how they track truth.
The author, Samuel Williams, poses 3 deeply uncomfortable diagnostic questions for any organization attempting to navigate this landscape.
Let's run through these, because if you are working in enterprise architecture, these questions are the ultimate litmus test of your infrastructure.
Question 1. Can you mathematically prove your AI outputs?
The emphasis is on mathematical proof, not just theoretical explanation.
Right. If a federal regulator, a compliance auditor, or a highly litigious stakeholder demands to see the exact origin, the structural integrity, and the legal consent trail of the data that underpin the specific AI decision, can you provide it?
Like, if an AI denies a small business loan and the business owner sues, alleging discriminatory data practices,
Can your data engineers instantly trace the algorithmic decision back to the exact rows of human-verified data?
most organizations would spend 6 weeks digging through system logs and still come up empty.
Exactly. Question 2. Do you know where your organization's sensitive data is actively going right now?
Not where the employee handbook dictates it should go.
But where the embedded agentic AI systems are autonomously transmitting it via WebSockets at this exact second.
And question 3, is your organization actively guilty of AI washing?
Are the cognitive capabilities you are selling to your board of directors and to your customers grounded in the hard engineering reality of your data architecture?
Or are you merely regurgitating the magical promises of a vendor's marketing brochure?
Answering those questions requires a paradigm shift within data management. It requires moving beyond the concept of data lineage and embracing the rigorous mathematics of data provenance.
Their article highlights a framework from TrueScreen that differentiates lineage and provenance, and I want to try an analogy to ensure the mechanical difference is crystal clear for you listening.
Let's hear it.
Okay, imagine you are purchasing a crate of organic apples at a premium grocery store. Data lineage acts as the travel itinerary for those apples. It tracks the operational movement and transformations of the product.
Right.
It logs that the apples left the farm on Tuesday, were loaded onto a refrigerated truck, passed through a regional distribution center in Ohio, and arrived on the store shelf on Friday. It maps the logistical path.
That is an accurate representation of lineage. It answers the question, how did this data get from system A to system B, and what format changes occurred along the way?
But data provenance acts as the irrefutable birth certificate and legal deed.
Yes.
Provenance tells me the specific genetic identity of the original seed. It proves whether the farmer used illegal chemical pesticides in the soil. It mathematically verifies whether the farmer held the legal, lawful right to own that land and harvest that crop in the first place.
Lineage maps the journey. Provenance proves the fundamental origin, authenticity, and ethical consent conditions of the item itself.
In an environment where regulatory bodies, institutional investors, and a highly skeptical public are demanding absolute accountability for generative AI,
Provenance is the only acceptable currency of trust. You cannot build a non-shrinking real data anchor if you cannot mathematically prove the provenance of the human data entering that anchor.
so how do we actually achieve that level of proof? We can't just rely on trust. We need cold, hard mechanisms.
The article points to 2 massive technological standards emerging to solve this: C2PA and zero-knowledge ML proofs.
Let's unpack the mechanics of these. What exactly is C2PA?
C2PA stands for the Coalition for Content Provenance and Authenticity. It is an emerging cross-industry protocol designed to embed a cryptographic, tamper-evident manifest directly into the metadata of a digital file.
Whether that file is an image, a video, a document, or a data set.
Exactly.
A tamper-evident manifest. Mechanically, how does that work?
When a human creator generates a piece of data, their software uses cryptographic hashing to bind a digital signature to the file.
Okay.
This signature records exactly who created it, the exact time it was created, and the exact software used.
And if a generative AI later alters that file, even slightly modifying a single pixel or a single line of text,
The cryptographic hash is irreversibly broken, and the manifest appends a new layer indicating exactly what the AI altered.
it creates an unbreakable digital watermark that travels permanently with the file.
Yes. So an AI model ingesting data can read the C2PA manifest and instantly know this is pristine human data, safe for the anchor, or this is synthetic AI output, reject it.
That's brilliant. But C2PA solves only the origin problem. When we deal with enterprise compliance, we also have to solve the privacy problem.
We do.
How do you prove to a regulator that your AI model is behaving legally without exposing the highly confidential data the model is actually running on?
This is where zero-knowledge machine learning proofs become revolutionary.
Zero-knowledge proofs. This is heavy cryptography, but it is vital to understand. How do you mathematically prove something is true while providing zero knowledge of the underlying data?
Think of it through a physical logic puzzle. Imagine you have a friend who is completely colorblind.
Okay, colorblind friend.
You have two billiard balls that are identical in weight, texture, and size. One is bright red and one is bright green.
Right.
Your friend believes they are identical in every way.
Right.
You want to mathematically prove to him that they are different colors without ever telling him which one is red and which one is green.
Okay. How do I prove the difference without revealing the specific colors?
You hand both balls to your colorblind friend and ask him to put them behind his back. You tell him he can choose to switch the balls between his hands or leave them as they are and then show them to you.
Got it.
When he presents the balls, you simply state you switched them or you didn't switch them. Because you can see the colors, you will always be 100% accurate.
Okay, I follow.
If he repeats this process 50 times and you correctly identify whether you switch them every single time, the mathematical probability of you guessing correctly by pure chance becomes 0.
Wow. You have mathematically proven to him that you possess a mechanism to differentiate the items without ever actually revealing the specific color data of the items.
That is the essence of a zero-knowledge proof. Now, apply that cryptographic math to an AI neural network.
Okay.
A bank needs to prove to federal regulators that its mortgage approval AI strictly adheres to fair lending laws and does not incorporate prohibited demographic data like race or religion into its algorithmic weights.
But the bank cannot hand over the actual neural network algorithm because it is highly proprietary, multi-billion-dollar intellectual property.
And they cannot hand over the training data set because it contains millions of unredacted social security numbers and personal financial histories, which obviously violates privacy laws.
Exactly. So what do?
By implementing zero-knowledge machine learning ZKML proofs, the bank's architecture generates a cryptographic certificate.
Okay.
This certificate allows the regulator to mathematically verify with 100% cryptographic certainty that the AI model executed its risk assessment algorithm exactly as legally mandated and that the prohibited data columns were entirely excluded from the mathematical weights.
That is incredible. The regulator verifies the integrity of the process without ever seeing the proprietary algorithm or the sensitive human data.
It solves the trust deficit with undeniable mathematics. It strips away the marketing hype, the AI washing, and the vague promises, and replaces them with verifiable proof.
And this leads us to the ultimate conclusion of Williams's thesis. The companies that will survive this current AI backlash, the companies that will actually turn that $40 billion investment into profitable revenue, are not the ones with the most aggressive marketing departments.
Not at all. They are the ones with the most disciplined data architectures.
The skills cultivated by traditional data stewards, metadata governance, architectural hygiene, real-time observability, and cryptographic provenance. These are the foundational requirements of the AI era.
They really are.
We've covered a tremendous amount of mechanical ground today. We started by diagnosing the public trust paradox and the severe financial realities of AI washing.
We examined the physical limitations of the hyperscale infrastructure, understanding why compute power is too precious to waste on the AI tax of corrupted data.
We unpacked the architectural physics of Postgres row storage limits, the invisible destruction of silent data drift, and the necessity of the data mesh.
We broke down the mathematical decay of model collapse and the urgent requirement to build a non-shrinking real data anchor to prevent predictive systems from blinding themselves to reality.
We exposed the invisible breach of autonomous agentic AI leaking data through WebSockets and outlined the 30-day inline inspection containment plan.
And we culminated with the shift from operational lineage to cryptographic provenance, utilizing C2PA and zero-knowledge proofs to mathematically guarantee trust.
But I want to leave you with a final provocative thought that builds on everything we've explored today. I want you to think specifically about the mechanics of that non-shrinking real data anchor.
It forces a profound reevaluation of what constitutes a valuable asset.
Exactly, because as we look toward the 2030s, AI systems are going to exponentially increase the volume of synthetic data they produce.
They are going to generate billions of hours of synthetic video, trillions of lines of code, and endless oceans of synthetic text.
The digital universe is going to be overwhelmingly synthetic.
A flood of homogeneous, probabilistically average output.
So if AI mathematically requires a massive, uncorrupted anchor of pristine human data just to maintain its functional sanity and prevent its own collapse,
Then in a future flowing with cheap synthetic data, will messy, idiosyncratic, verified, unautomatable human experience become the most scarce and highly valued corporate asset on the planet?
by trying to automate everything, have we inadvertently engineered a system where the most expensive and vital resource is simply undeniable, cryptographically proven human reality?
It's definitely something to think about as you evaluate your own data architecture.
It really is. Thank you for joining us on this deep dive. Keep questioning the consensus, stay rigorous in your governance, and keep a very close eye on your data pipelines.
Thanks for checking this out today. Don't forget you can connect with other data professionals worldwide on our growing school platform. It's all linked in the description, so pop along, come in, have a chat, and check out the exclusive resources there for data professionals like you. And if you haven't done so already, please feel free to like, share, or subscribe to the channel.